All right, so you liked the chain rule, you liked the first video, and you're back for some more chain rule. You came to the right place. Either that or you just want to get a good grade and you want to know how to do the problems. Either way, let's look at something again. Let's say if we have y equals f of g of x. So we talked in the first video how to take this derivative. Take the derivative of the outside, leaves the inside the same, and then multiply by the derivative of the inside, which again is what we've been doing with the general power rule. General power rule is actually the chain rule. Anyway, so what we're going to do is let's look at this problem from a different point of view. So this is an exploration here, guys. So if g of x is some u, then what is this? This is f of u. Okay. So if we want to take the derivative, right, we know from the chain rule that the derivative is the derivative of the outside function, leave the inside the same, and multiply by the derivative of the inside, which again is g prime of x. Look at what we've got here. This y prime, that's dy dx. F prime of u is going to be df du. Or we can think about it as dy du. And g prime of x, that is du dx. And something has gotten moved. You go back here. This is an alternate statement of the chain rule. One way to kind of remember it, and this is not mathematically correct, but it's sort of how things work. These aren't actually fractions, so we can't cancel, but it kind of works for remembering, right? If those du's cancel, dy dx is dy dx, right? That's a good way to remember this little statement of the chain rule. This is just alternate statement of chain rule. All right. All right, so let's use this. Let's use this. Let's go to the next problem, next page. Example 1, here we go. Nope, not example 1, we already did that. Example 4. Find dy dx or y equals, I couldn't find the problem, u to the 5th, no, this will fit, u to the 5th minus 2u cubed plus 8, where u is equal to x squared plus 1. So again, we don't have to use the chain rule here. We could just plug u in, right? We just could plug this in and then take the derivative normally. But let's use the chain rule here. Why not? Remember dy dx equals dy du, du dx. So find the derivative of y with respect to u. Oh, that's not too bad. Just the power rule. Derivative of y with respect to u is going to be 5 u to the 4th minus 6u squared plus 0. All right, so that's that first piece, right? This is the dy du right here. We multiply that by du dx. The derivative of this with respect to x is just 2x. Right? So that's the chain rule right there. But we should have our answer all in the same variable. Usually we like our answers all in terms of x. So that's what we're going to do here. I'm going to write the 2x in front. You don't have to, but we usually write the 2x part in front. 5 times u, which is x squared plus 1, to the 4th, minus 6 times u, which is again x squared plus 1, squared. And there's a little bit of a way that we can simplify this, but I'm okay leaving this as our final answer. All right. Again, right, this u is this u, right? And this u is this u. We're just replacing what is u. Just put it in right there. Okay, that's the chain rule. Which, if you did plug in the x squared plus 1 initially, it'd be another way of doing the general power rule. Any questions? If you have them, don't ask here because this is a recorded video. But you can ask me email, Canvas, Slack. All right, here we go. Example 5. We got tons of examples here. All the better for you to see these things. So let's say f of 1 is going to be 1. Let's say f prime of 1 equals 5. And maybe f prime of 3 equals 2. So here's a bunch of bonus information about these things. And I'm going to ask you some question that makes you use some of this, or maybe all of this, who knows. Part A. I want you to find the derivative with respect to x of g of f of x. This is a lot of parentheses and brackets, all evaluated when x is equal to 1. So remember, this is take the derivative like normal. Weather outside's kind of wonky today. Take the derivative as normal, and then at the very end, plug in 1 for x. And I don't know what these functions are, but I know a couple of things about them. All right, so let's take the derivative. By the chain rule, it says take the derivative of the outside function, g prime, leave the inside function alone, and multiply by the derivative of the inside function, f prime. Once we're done, we're going to plug in x equals 1. So we are basically done. Let's get plugging in. Plug in. We get g prime of f of 1 times f prime of 1. And luckily, we know these things, right? What is f of 1? F of 1 is just equal to 1. What is f prime of 1? F prime of 1 was 5. I love using the colors. So just use color. Even if there's not a good reason to use colors, I'm using the colors, all right? This becomes g prime of f of 1 we said was the same thing as 1. So we replace it, right? Times f prime of 1 we said was 5. We replace it with the 5. And then finally, what is g prime of 1? G prime of 1 is 4. So we're left with 4 times 5. I know that. The answer is 20. And there we go. And I'm going to do a little scribbling over here. Now we have all the colors in the same one. Now let's do another one. Okay. Find. Ooh. All right, we're going to have to go back and forth a little bit. Part B. Find the derivative with respect to x of g of x. Looks a little weird, but we're going to do this the same way as before. Derivative of the outside function, leave the inside function alone. Multiply by the derivative of the inside function. Plug in 1 at the very end. It looks weird because it's the same function on the inside and the outside, but we follow the same steps. Then we plug in 1, that's going to give us g prime of g of 1 times g prime of 1. My g's look really weird today. The g prime of 1. G prime of 1 is 4. Okay? So replace the second thing with 4. We also have to know what is g of 1. That's what goes on the inside. G of 1 is 3. Wait, do I know what g prime of 3 is? I feel like I didn't write down all the information that you need. You need to know what g prime of 3 is, right? There's no way I messed this up, right? G of 1 is 3. We have to know what g prime of 3 is. And g prime of 3, everyone, is equal to 6. That was given in the original problem. G prime of 3 is 6, so we get 6 times 4, or 24. All right. That's how you do this. Let's do a couple more. Again, we're just trying to I'm just trying to show you a couple examples of using this chain rule that look similar to the book problems. Giving you just guys something to go off of. Okay. Example 6, find d dx of f of g of x, or f of x equals the square root of x, and g of x equals x squared plus 1. So you have two ways of doing this problem. Two choices. You can just find f of g of x. F of g of x is just what happens when you plug in g into f. So we'll have the square root of x squared plus 1. Or if you want chain rule practice, we use the chain rule here. The derivative is going to be the derivative of the outside function. Leave the inside function alone. Multiply by the derivative of the inside function. All right. So what is the derivative of the outside function? All right, this is x to the 1/2. Its derivative, f prime of x, equals 1 over 2 root x. We showed that in an earlier example. So just plug g into this derivative. G gets plugged into this derivative. Replace all the x's in the derivative with g. Get 1 over 2 times the square root of g, which is x squared plus 1, times g prime, which is 2x. We get a little cancellation. 2 on the top, 2 on the bottom. And we get our final answer, which is just x over the square root of x squared plus 1. And again, if you kind of did this the other way, if you just found f of g of x before, right, that's plugging g into x. It's going to be x squared plus 1 to the 1/2 power. Square root is the same as 1/2. So its derivative, we could use the generalized power rule. Same thing as the chain rule. 1/2 x squared plus 1, subtract a power, multiply by the derivative of the inside, which is 2x, which totally fits right there. And the 2's are again going to cancel. We'll get the same answer. All right. You've had it in you. You've had the chain rule in you this entire time. You've had the power. You just had to see it. Don't know where I'm going with this. Find the equation. Ooh, I love finding equations of tangent lines. Find the equation or an equation of the line tangent to y equals x divided by the square root of 2 minus x squared. That looks nice. That 1. We've got a quotient rule on our hands. This is the quotient rule and the generalized power rule. What is this doing in the chain rule section? Generalized power rule is the chain rule. Oh man, where I can really get this pencil right up in your face. All right, so equation of tangent line. We need to find the slope. The slope is derivative. Don't forget that. Slope is derivative. So we need to find the derivative. So y prime. Again, let's let this be our f and this be our g. Quotient rule says derivative is low d high minus high d low, square the bottom, and away we go. All right, so g is our bottom function, that's square root of 2 minus x squared, times f prime. Oh, derivative of x is just 1. Minus f, which is x. Derivative of g, derivative of g is a little harder, right? G of x, you can write this as 2 minus x squared to the 1/2 power. And now we can use the generalized power rule, aka the chain rule, on this. Derivative of that g function, right? Bring the exponent down, subtract an exponent, leave the inside the same, and multiply by the derivative of the inside, negative 2x. All divided by the bottom function squared. Woohoo! Looks beautiful, right? We're nowhere near done this problem, but we've done the hard stuff. Hard work is already finished. Look at what this becomes. The top, this first term, is just the square root of 2 minus x squared. The second term, well, we got a lot going on in the second term, right? So we have a negative times a negative. That's going to turn them into positives. We have a 2 times a 1/2. That's going to cancel. X times an X is going to be an X squared. And then 2 minus X squared to the negative 1/2 power. And the bottom cancels out square root squared. Beautiful. And there's some more simplifying that we can do right here, but we don't actually have to. So you could keep on simplifying, or you could just plug in now, right? We want to find the slope when X is equal to 1. So we specifically care about the slope when X equals 1. So we just plug in 1, right? We're going to get Y prime equal to the square root 2 minus 1 squared, which is 1, plus 1 squared, which is still 1, times 2 minus 1 squared, still 1, the negative 1/2, all divided by 2 minus 1 squared, which is 1. So take a couple steps and simplify this, but you actually get some really nice things. This is 1. This is 1. This is also 1. So we have 1 plus 1 over 1. That should be 2. So our slope of our tangent line is the slope of the function, which is the derivative. The slope of the tangent line right here is just 2. So we're almost done. Let's actually just do it all on this page. Kind of go off to the side here. We're almost done. Remember, the equation of a tangent line is just y minus y1, or 0, equals the slope times x minus x0. So these are the coordinates of that point. So we get y minus the y coordinate, which is 1, equals the slope, which is 2, times x minus the x coordinate, which is 1. That is a perfectly good equation of a line. That'll be our final answer. And once you go here, we'll go on a little journey over here, and go up there. So let's check our answer. You know, hopefully our answer is correct. Hopefully this is indeed the equation of the tangent line. So we're going to go over to our computer or our graphing calculator. We are going to show this off. I had a hotkey for this. I don't remember what the hotkey was. Is it this? No, it's not. Oh, I have the wrong scene. That's why. This should. Oh, this is not it. 1 second. Professional production value. Is it this one? Hey, it's that one. Great. Let's graph this and see what we got. So we're looking for the tangent line to this equation. We're looking for the tangent line at the point 1, 1. So we're going to type in a line. Wait, why is my Twitch chat popping up again? No idea what's causing that. Where are you guys coming from? Hey, this is bizarre. Hey, there we go. All right. So hopefully we have a tangent line at this point. Let's check it out. Y minus 1 equals 2 times x minus 1. Oh, would you look at that? Isn't that beautiful? We got a nice tangent line right there. Oh, that's the right answer. That feels good. All right. So we check our answer and we know that we're right. Anyway, these are some applications of the chain rule. All right. And here we go. Good luck.